In finance, there is a simple, universal rule. A dollar in your hand today is worth more than a dollar tomorrow. Businesses use this principle to evaluate major capital investments. They look for a positive net present value, meaning the future cash inflows generated by an investment will outweigh the initial cash outflows required to start it. This math applies directly to the technology your company buys. Purchasing a fleet of laptops or a rack of servers is a major capital investment. When hardware specs don't align with operational needs, businesses risk paying for processing power they don't use, or worse, losing hours of billable productivity to systems that simply cannot keep up. Learning to evaluate hardware functions allows you to treat these physical assets as strategic investments, ensuring each machine contributes to a measurable return. To see how this works, let's look inside. The Central Processing Unit, or CPU, is the brain of the device where all calculations take place. Whenever you ask a computer to do something, the CPU executes those instructions by running through a rapid sequence called the machine cycle, which happens in 4 distinct steps. First, the processor fetches data from memory. Then, it decodes that data into readable binary form. Next, the processor executes the required task, and finally stores the results, repeating the cycle. The performance of a CPU is defined by its cores, the physical processing components on the chip, and its clock speed, measured in gigahertz, which tells you exactly how many billions of these cycles can happen simultaneously. A data entry team doing light spreadsheet work only requires inexpensive single-core processors, but a marketing agency rendering 4K video files requires multi-core processors, executing multiple sets of instructions at the exact same time. Buying massive CPU power for simple tasks wastes capital up front. On the other hand, buying weak processors for complex tasks destroys expensive employee time as they sit around waiting for files to load. The most common source of confusion in computer hardware is the difference between memory and storage. Think of them as an active workspace versus a permanent filing cabinet. Memory, primarily known as RAM, or random access memory, is a temporary volatile workspace. It holds the data your processor is using right now. Because it is volatile, it completely erases all data the second the power switch is off. If you run an accounting firm where staff keep massive, complex financial models open all day, you need high RAM, like 16 gigabytes or more, to give the processor enough active workspace to prevent catastrophic system crashes. Storage is the non-volatile filing cabinet. It keeps your important data intact indefinitely, retaining those digital files even without power. You can buy traditional hard drives, which use spinning magnetic platters to hold data, or you can opt for solid-state drives, which are entirely electronic with no moving parts. For traveling sales representatives, a business should invest in solid-state drives. Lacking fragile moving parts, dropping a laptop won't result in catastrophic data loss. Understanding the temporary nature of memory versus the durability of storage ensures you invest in the correct hardware to protect your data. When we scale out from individual components to complete computer systems, the guiding rule remains the same. Hardware form follows business function. At the most specialized level, we have embedded computers, integrated into larger physical systems, running small, real-time operating systems. For example, a logistics company might install programmable smart thermostats across their warehouses, automatically optimizing the heating to slash utility overhead. As an organization grows, they scale up to servers. A law firm must deploy a server to centralize file access and maintain strict client security. The highest tier belongs to mainframes. These are incredibly powerful computers used by massive organizations to process immense volumes of data simultaneously. A global bank cannot rely on standard servers. They must use mainframes to handle millions of secure credit card transactions per second without crashing. Your network hardware must directly mirror the scale of your daily operations. Choosing the wrong tier creates either crippling bottlenecks or massive wasted overhead. At every level, the hardware a business chooses determines the speed and reliability of its internal systems. Bits, bytes, clock speeds, and gigabytes are tools. Their only purpose is to process organizational information faster and more securely. A professional who understands the specific functions of processors and memory sees these components as line items in an ROI calculation. Future technology purchases can be mapped directly to expected business outcomes. Think about the day-to-day operations of a business you're familiar with. What is one specific hardware upgrade that would generate the highest return on their capital? Let us know your rationale in the comments below.